Hello, this video is to learn the fourth special property or trick for finding limits algebraically. Before we can do that though, we need a little property first that's going to help us out. So here is the property. It says that if you have two functions, f of x and g of x. So if f of x is less than or equal to g of x, when x is near c, as we usually have here, then if that is the case, the limit as x approaches c of f of x will be less than or equal to the limit as x approaches c of g of x. Okay, and this, you can kind of picture what's going on here just by thinking about the y values of the functions. So remember, these are y values that we're talking about. If f of x is less than or equal to g of x, then our limits are going to have that same relationship. The limit of f of x is going to be less than or equal to the limit of g of x. So let's sketch a little picture here just to clarify this. So let's put in a value c, and we want our x's to be near that value. Okay, now we need two functions, and we want g of x to be larger. Okay, so g of x is greater than or equal to f of x. So let's say g of x might do something like that. And f of x will come in and be less than or equal to g of x when x is near c. Okay, so f of x needs to be smaller. It could equal g of x at some point, but less than or equal to g of x. Okay, now on here we can see that same relationship with the limits. So remember, for your limits on a graph like this, you would find the limit of g of x by going to either side of x equals c, okay, and then you would approach x equals c from both sides. So you would start here maybe, and then bring your fingers together until you locate that limit value. And it does match up from both sides, so we have a limit here. We would say this is our limit as x approaches c of g of x. Okay. Now we would do that same thing for f of x. All right, you would start to either side of x equals c, and you would travel along that f of x function until you see what limit is being approached. Okay, right in here. All right, there's our limit for f of x. So that's limit as x approaches c of f of x. And so we can see that, yes, the limit as x approaches c for g of x is greater than the limit as x approaches c for f of x. Okay, and so that'll hold true for any functions that have that type of relationship. Now, what this leads to is what we're interested in. This is trick number 4 for finding a limit algebraically. This is called the Sandwich Theorem or the Squeeze Theorem. Our book uses Sandwich Theorem. Squeeze Theorem is also very common. I think that's what my book used when I was learning calc the first time through. So yeah, it's the same idea either way. So here's the setup for this. If we have g of x, and that is less than or equal to f of x, and f of x is less than or equal to h of x, when x is near c. And we have this other criteria. So this is a big and, but the limit as x approaches c of g of x equals the limit as x approaches c of h of x. Okay, so those two outer functions have the same limit. We'll just call that value L for limit. Okay, so if those things are all true, then the limit as x approaches c of f of x, the middle function, that equals L also. All right, so picture time. Okay, let's set up some axes here. I'll use different colors for all the functions. And let's give ourselves a value c to look at. All right. Now let's start putting our outer functions on there. Okay, notice that in our kind of inequality sandwich here, we have, that's one reason you can call it the sandwich theorem. It is like an inequality sandwich. These two on the outside there, those are the breads, g of x and h of x. And then finishing off the sandwich, your fillings in the middle is the function f of x. So that's like your meat and your veggies or whatever in the middle of the sandwich. So we've got this sandwich theorem. All right, so let's set up a graph sandwich here. Let's put the top piece of bread, h of x, on our graph. And your graph might vary a little bit, but just make sure you're meeting the qualifications of our theorem. So here's h of x. And let's put in, let's see, what special color could I use here? Let's make this orange, sure. Let's make g of x orange. All right, there's our bottom piece of bread. It needs to be less than or equal to f of x, which isn't on our graph quite yet. But notice that we also have some information about limits here that we haven't put on quite yet. The limit as x approaches c of h of x equals L. So as we're approaching c here on the h of x function, okay, that limit that we're approaching is going to be L. So let me mark that value right here. Okay, because notice that our theorem setup here, the requirements say that the limit as x approaches c of g of x has to equal L as well for this to work. So g of x is going to come in here. It's a smaller function, but it has to have that same limit. So as x gets close to c from both sides, g of x also has to approach that value L in the y direction. Okay, so there's like our two pieces of bread, essentially, h of x and g of x. And then we'll put in our fillings in the sandwich with f of x. We'll make that, dark purple here. Okay, so f of x has to stay between those two functions. It could equal g of x or h of x at some point, but f of x needs to be between g of x and h of x when x is near c. Okay, so f of x could come through. Maybe it equals g of x right there. Okay. Well, if it's got to stay between the two functions, it is really getting guided right in here. There's nowhere else it can go really except towards that limit value of L. All right, same thing from the other side. For f of x, I mean, it could do whatever it wants as we get away from x equals c, but as we get closer and closer to this x value, x equals c, f of x cannot escape this sandwich. It is getting forced to have that same exact limit. So that's what's going on with this sandwich theorem or squeeze theorem. F of x is getting squeezed or sandwiched between the two other functions, and it has nowhere else it can go except to go to the same limit. So we'll see how to use this in the next video.